All right, so here's a couple more examples on it to make you better at these. Same directions. Find where it's increasing and decreasing, and find any relative extrema. So this is going to be a little harder in the derivative sense. So I want to show you one that's a little more difficult. So first thing, since I want to find critical numbers, I need to find the derivative. And you need to take the quotient rule. We got our low and our high, right? So remember, quotient rule is low d high, so 2x, minus high d low, which is 2x, over low, x squared minus 9 squared. Okay, and then we're going to clean that up because it's going to be really hard for me to find out when this thing equals 0 and when it's undefined if it's not cleaned up. So let's clean this up a little. 2x to the third minus 18x, and here I got minus 2x to the third. Oh, well, that's going to clean up nicely. Don't mess with the bottom. It's nicer in factored form. But those two cancel, and you get negative 18x over x squared minus 9 squared. Okay, so I want to find out when this is 0 and when it's undefined, because our critical numbers are, they happen 2 times. Critical numbers happen when f prime of x is 0 and when f prime of x is undefined. Right? So we kind of want to split here and say, okay, fun little fact here, a fraction is worth 0 when the top is equal to 0. So all you have to do for this one is set, this is when negative 18x equals 0 is when this whole fraction will be 0. Because like 0 over 10, 0 over 20, that sort of thing. Alright, so I just got to solve that. Well, okay. Divide by 18. You get. Alright, there's a critical number. I also want to find out when this thing's undefined. Well, if you remember when we were doing continuous and not continuous and asymptotes and wholes and stuff like that, a fraction is undefined when the bottom equals 0, because you're not allowed to divide by 0. So you basically set the top equal to 0 for this side, set the bottom equal to 0 for this side, square root both sides, and then solve for x. Move the 9 over, square root. Be careful here because a lot of people would just say 3, but we're not rookies. We know it's plus or minus 3. Alright, now that's all our critical numbers. This is more intense than last time. Last time I only had one answer. So what do I do with that? Well, basically, you got this big old rectangle here, and you got to split it 3 places. You got to split it when x is negative 3. You got to split it when x is 0, and when x is positive 3. Alright? Put them in numerical order, because I'm going to be splitting up my interval. So it wouldn't make sense if I went 0, negative 3, positive 3. You want to think of this like a number line. Because from negative infinity to negative 3, my graph is going to behave one way. From negative 3 to 0, I'm just using these as like my breakpoints. From 0 to 3, and from 3 to infinity. Okay, so I'm going to basically have some craziness going on here. Alright, and then we need to pick a test point, right? Let's pick any point on this interval, like negative 4. Why not pick the smallest number I can? How about on here, negative 1? Between 0 and 3 is a 1, and between 3 and infinity, I'll pick a 4. You're not allowed to pick the endpoints. We already know what their derivatives come out to 0. So now I use f prime of x, and I'm looking for positive or negative. I want to know, is my graph positive or negative there? So if I put a negative 4 in here, into, not here, but if I put a negative 4 into here, f prime of x. So you could type it in your calculator, but I like to use common sense, because the top is a negative 18 times a negative 4. So So the top will be positive. The bottom of the fraction will be positive because it's squared. So if you ever have a positive over a positive, your answer is positive. Similarly, if I put in a -1 on top, you're going to get a positive over, the bottom's always positive, so that's a positive. And then I'm going to have, if I put a 1 in here, the numerator is going to be negative. The denominator is going to be positive. So that results in a negative answer. And lastly, if I put a 4 in here, the top's going to be negative, the bottom's going to be positive always, because it's squared. And that results in a negative. So basically you have positive, positive, negative, negative. Which means my graph is increasing on this section, because its derivative is positive, decreasing on this section, decreasing on this section. So your graph goes up, it goes up, it goes down, it goes down. So the only place a max or min can occur is right here where it goes from up to down, because you're like graphing that, right? It's going from up to down. Up to up, these are probably asymptotes, I'm guessing, because my original graph had those denominators equal 0. But I do know I have a max right here. Now that's at the point 0, something. How do I find the something? You plug in the 0 to the original equation. So you're going f of 0 is 0 squared over 0 squared minus 9. Also known as 0. So you have a maximum there. Guarantee if you would draw it out, you'd see there's a max there. You also know it's increasing from negative infinity to -3 unioned, which means along with, -3 to 0. You can't just say, because I think that's an asymptote, so we'll get into that stuff later, but 0 to 3 unioned with 3 to infinity. So there's our answers. It's increasing on these chunks, it's decreasing on these chunks, and there's a max there. Okay, last problem. All right, same directions. So first thing I would do in this problem, if I'm going to need critical numbers, I want to rewrite the problem before I take its derivative. I would much rather see this guy as to the 2/3. That's one of our rules, right? And then I can take its derivative and find out when it's 0 and undefined. That's 2/3. Ninja rule coming up. X minus 1 to the -1/3, because I subtract 1, times the derivative of what was inside, which in this case didn't turn out to be much. And then I'll write it a little more nicely. Okay, I want to know there already is a fraction line, right? So when this has a negative exponent, it means it drops down. So it's a 1/3 on the bottom. All right, so remember, critical numbers occur when the derivative is 0 or when the derivative is undefined. Okay, so in this case, when is the derivative equal to 0? Well, remember, a fraction is equal to 0 whenever the top is equal to 0. So you set the top equal to 0, and then your brain melts because that's not even possible. This is never. Sometimes you'll have a case where the top's never equal to 0. Sometimes you'll have a case where the bottom's never equal to 0. This is one of those times. You can never turn a 2 into a 0. So I don't have a critical number there. When will my fraction be undefined? When the bottom equals 0. Right? When 3 times x minus 1 to the 1/3 equals 0. Okay. I can do the algebra here. Right? I'm an algebra all-star. Divide by 3. How do you undo cube root? You cube both sides. Well, 0 cubed is still 0, right? And then I don't need the plus or minus this time because it's an odd number. Anyway, you have one critical number. That means good news. My graph, or my table, only splits at one spot. So it doesn't have to be as big as last time. You'll see sometimes you'll have it split once, sometimes you'll have it split a bunch of times. interval, negative infinity to 1, and, whoops, 1 to infinity. Now I pick a test point. Hopefully you're getting pretty good at this. I want to pick any number between negative infinity and 1. How about 0? And a 2. Right? Pick small ones. And then I want to test them in the f prime of x if it's positive or negative. So I want to know is my derivative, not my f, is my derivative positive or negative when I put a 0 in? So I want to go back up here and put a 0 in, right? So when you put a 0 in here, you're going to have 2 over 3 times negative 1 to the 1/3. That makes you wonder what happens when you take negative 1. Oops, you can't even see what I just did. Oh my gosh. Oh well. Catch up. Pause it here. I was just writing off screen. My bad. So if I put in a negative 1 to this equation, negative 1 to the 1/3, you could type in your calculator, you'll see it comes out as a negative number. Remember, I never care what the number is. I just care is it positive or negative. And same here. You're going to put the derivative 2 over 3 times 2 to the 1/3. Well, that's a positive. Everything there is positive, so it's positive. So you have decreasing and then increasing. It's increasing. What's cool is it's increasing on this whole interval. You don't have to wonder, are there other places that going up or down? You guarantee, since we did this and there's only one critical number, that these are the only places it's decreasing for that whole interval. And it's increasing for that whole interval. I guarantee if you pick 20 more numbers between 1 and infinity, you'll keep getting positives on the derivative, which means it's always increasing, which means it looks like that. Right? Decreasing looks like that. And if you go from down to up, you have a min. So this is a min at 1 comma something. Remember, you always get that something by plugging the x value into your, not prime, but into the original equation. So I'm going to plug it into that guy. So we're going to say that's the cube root of 1 minus 1 squared. Okay, so cube root of 0 is 0. So we have 1, 0 as your thing. This is actually a cusp, which is weird. It's one of the rare cases where you have the derivative undefined, but the actual point exists. It's not an asymptote. And if you're looking at it, it kind of looks like this. You could graph it on your calculator and see. But it's a minimum that looks like that. It's kind of like looks like a seagull. All right, that's it. Talk to you people later.